In previous recordings, we've talked about the exceptional performance of the RFeye node, we've talked about dynamic range, and we've talked about the noise figure. It's something that we publicize very clearly in our data sheets, the typical sort of noise figures that you can expect. They're extremely low. For example, here for the 20-6, it's 8 dBs typical across most of the frequency range. When you take a look at competitors' units, it's actually very, very difficult to see the figures. You have to hunt for a long time, but the data is out there, and you see for equivalent devices, you see noise figures of 12 to 15 dB. What does that mean in real life? So it's a spec game on the sheets, but I've got a cute way of using RFeye Sight, our real-time analysis tool, to be able to show you what that difference looks like and to visualize it. So what I've got two nodes side by side, either side of Cambridge, so we can see them side by side for comparison. The first node has actually set up with the parameters of our 20-6, and here we can see the 8 dB noise figure. The second node we've actually set up as a inferior product from a competitor, and I put a 15 dB noise figure. Everything else is absolutely identical between those two nodes. All I've done is change the noise figure. One of the many tools inside of our RFeye Sight allows us to visualize the RF propagation analysis. So let's simulate a signal at 2.4 gig, Wi-Fi, 12 dB output power, and actually take a look at what the RF propagation analysis looks like for those two different nodes. And I think visually you can see a massive difference. We just do a quick measurement here. So we're going over 15 kilometers, pi r squared, that means about 240 kilometers squared. Let's do the same measurement across here. Let's call that 7 kilometers, pi r squared. We're about 110 kilometers square. That's a really huge difference in the propagation area over which we can reliably detect that type of signal. What that means is not only do we normally have a very strong price advantage against competitive units, but if you're looking to put a series of receivers into the field to provide coverage over a wide area, such as a city, then you're actually having to use less nodes with the RFeye solution due to this enhanced capability. So it's very easy to visualize the difference in this, and if it's something that you're interested in looking into more, by all means take a look at the CRFS blog. My colleague have actually put some different calculations up there for people to be able to see. Or don't hesitate to contact us. We can use the RFeye software and actually simulate not only what a solution would look like using the RFeye solutions, but what would that look like using inferior products too, and really allow you to look at the trade-off between number of nodes, cost, probability of intercept, and the ability to meet your RF spectrum monitoring and geolocation challenge.